Hello again, and welcome to Lesson 12 of Hotard's Algebra 2 Remote Learning Channel. Today, I'm filming from my old abandoned classroom, which has been shuttered due to the COVID-19 pandemic. As you can see, students, the desks are still in rows from our last day together when we were testing. As I look around this room, it brings back so many memories. I think of the countless heads that have napped on these desks during the middle of algebra lessons over the years, and of many, many inappropriate comments that have been scribbled and passed on the student dry erase boards. It's good to be a teacher. Now, today, from the comfort of our old classroom, we will be finishing up our unit on rational expressions. Today, specifically, we will be solving rational equations. I know you're excited about that, so here it comes. We're going to begin this lesson with a semi-real-life example, just to start us off. It says Jesse pitches for the baseball team and wants to improve his batting average. For those of y'all that don't know, batting average is the ratio of hits to at-bats. Right? To date, he has 10 hits out of 40 times at bat. So 10 out of 40, that's 25%, so that would be a 250. You don't say the decimal. All right, and then he wants to improve his batting average to at least a 320. He wants to go from 250 to a 320. If he gets a hit every time he bats, how many consecutive hits does he need to reach his goal? So really quick, let's just talk about what an equation would look like for this. Right now, he's hit 10 out of 40, so 10 out of 40 is what he has. He wants to get to a 320, to 0.320. So if he goes to bat and hits every time, so let's say the number of times he has to hit, that's X times, or whatever letter you want to use. Would I be adding that X, that number of times he hits it, would I be adding that onto that 10 or to that 40 to get it equal to 320? I would be adding it on to both, all right? If he goes to bat and he hits it, then you're adding it on to the number of times he's actually hit it and the number of times he's attempted to hit it. So my equation would look like that. 10 plus x over 40 plus x equals 0.320. Now, to solve this, a couple of things you could do. Yes, you could just try different numbers. See, what does 11 out of 41 come out to be? What is 12 out of 42? And the answer to this problem would be 5, all right? If you just try different numbers. If he hits 14 out of 44, that'd be a 318, still a little too small. 15 out of 45 would be a 333. That would be big enough. That would reach his goal. So yes, you could do it that way, but we're also going to look at how you can solve this algebraically without just trying a bunch of different numbers, because it's not always going to be that quick and easy to solve. So let's come back to this problem. Let's look at a few other examples. Solving these rational equations. Again, rational equation is just an equation that has fractions in it. All right, these are fractions. They have algebraic expressions in the fractions. So to solve these, I want to multiply, for all these problems, I want to multiply by LCD, by least common denominator. Now, we talked about finding common denominator the past 2 lessons when we were adding and subtracting. So it's the same LCD we've been doing. We're going to start with monomial denominators, no plus or minus. So if you have, in this one, we have a 2, an R, and a 2R. Anything that shows up in the denominator has to be included in the LCD. So this one's got a 2, this one's got an R, this one's got a 2R. What do you think the LCD is? It's 2R. Now, unlike adding and subtracting where we had to change all the fractions into 2R denominator, this time my goal is I'm actually solving the equation, so I want to get rid of the fractions. So I'm going to go through, I'm going to multiply the whole equation, everything, both sides, by that LCD, by 2R. Now when you're multiplying fractions, you're multiplying the top, but you're also dividing out the bottom. So the reason I'm doing this is it should cancel out the fractions completely. There should be nothing left on bottom. I'm going to divide out what's on bottom first, then multiply what's left. So 2R divided by 2, the 2's cancel. What's going to be left right there? Just the R times the 5, going to give me 5R. Okay, so again, I took that LCD, I divided out the bottom, and then whatever was left, I multiplied by the top. Okay, 2R divided by 2 is R, times the 5 is 5R. Doing the same thing over here, I'm multiplying this side by 2R. So in this fraction, 2R and 2R, they completely cancel out. Nothing to multiply left, so what's the only thing left in this fraction? r minus 2. And then plus, now in this last one, 2 over r times 2r. Again, this time I could divide out the r's, the 2's still left, times this 2. 2 times 2 is 4. All right? One way you could check to make sure you have the correct common denominator is you should have nothing left. You should be able to cancel out everything on bottom of these fractions. All right, if you can't, then there's probably something wrong with your LCD. So now, once I've done that, it's just a matter of solving this equation. All right, I can get these r's together. I could subtract r, cancel that, going to give me 4r, equals, and I can go ahead and combine these like terms. Negative 2 plus 4 going to be positive 2, and then just divide by 4. R is going to be 2/4, which is 1/2. Or again, just finding that common denominator. Second problem, I'm going to do the same thing. I need to pick out my LCD, least common denominator. I see 6b squared, 2b squared, and 3b. Let's just start with the numbers. 6, 2, and 3. Least common multiple of those. If I count by 6's, 6, 12, 18. Count by 2's, 2, 4, 6, 8. Count by 3's, 3, 6, 9, 12. What's the first number to show up in every list? It's 6. So LCD, least common multiple of the numbers is 6. And then most of them have b squares. This one just has a b. I need to use b squared. So again, I'm going to go through. I'm going to multiply each part of this equation by 6b squared. All right, now in the first fraction, 6b squared completely cancel out. What's the only thing that's left? Just a 1. Equals, now over here, I'm going to need to divide these. 6b squared divided by 2b squared, going to give me, is it 3b squared or just 3? It's just 3. Times that 1 is going to be 3. Plus, now over here, 6b squared divided by 3b, careful with this one. When you divide this out, it's going to be 2 what? 2b. Not just 2. It's b squared divided by b. And then 2b times that 1 that's left, going to be a 2b. So again, my common denominator canceled out everything on bottom. Now it's just a matter of solving this easy equation. Get b by itself. Subtract 3, I have negative 2 equals 2b. Divide by the 2, that's going to be negative 1 equals b. So again, find a common denominator. All right, now at this point, it would be a good idea to go through and try a few problems on that practice sheet. All right, the first 4 problems on that practice sheet all have monomial denominators, so you can check your answers after you've tried those first 4, and then come back and finish the video. Did you do it? Of course you did. All right, so now let's look at what happens when the denominators are not monomials. So again, just like the last lesson that we did. So example 3, there's only one denominator. It's x plus 1. So that automatically means LCD in this problem is x plus 1. All right, so I need to go through and multiply both sides of this equation by x plus 1. So in this first one, the fraction, x plus 1 on top, x plus 1 on bottom, cancel out. I'm left with just x squared minus 4 equals. Now the other side of the equal sign, there is nothing on bottom to cancel out with x plus 1. I'm going to have to multiply this whole x plus 5 times this whole x plus 1. I'm going to have to FOIL it. X times x is going to be x squared. X times 1 is 1x. 5 times x is 5x. Let's just go ahead and combine them. Make it a plus 6x. And then 5 times 1 plus 5. So now I'm seeing this equation. I know you're thinking, wait, x squared, am I going to have to factor it? Well, not necessarily, because look what happens if I bring this x squared over to this side. I subtract x squared, it's going to cancel out on both sides. So I have negative 4 equals 6x plus 5. Now just solve that. Subtract the 5. So negative 9 equals 6x. Divide by that 6. So x is going to be negative 9/6, which you can reduce to negative 3/2. 2 more examples. All right, this one right here, this time is not all monomials on bottom. I have x and I have x plus 2. I have a monomial and a binomial. So if you remember from your last lesson, LCD, if you have a monomial and a binomial, or if you have 2 different binomials, what do you do to get the LCD? You put them together. Least common denominator would be x parentheses x plus 2. It'd be both of them. So I need to go through and multiply each of these fractions by that LCD, by x parentheses x plus 2. Each part of the fraction. So in the first fraction, x's cancel out. I have this x plus 2 times this 2. I need to distribute that 2 to this. So that's going to give me 2x plus 4. Now, second fraction, x plus 2's are going to cancel. I'm left with this 1. Remember, it's a negative 1 because we're subtracting. Negative 1 times this x. So that's going to be a minus x equals, and in the last fraction, this x and this x cancel out. I'm left with this 3 times this x plus 2. Distribute that. That's going to be 3x plus 6. So let's just go ahead and start combining like terms. Get these together. I have 2x minus x going to give me 1x. All right, and then I have plus 4 equals 3x plus 6. Let's subtract that x from both sides. We can also go ahead and just subtract this 6. Let's just do it all in one step. So that's going to be negative 2 equals, that's gone, that's 2x. And divide by that 2, going to be negative 1. One more problem. Last example. Okay, look at the denominators this time. X plus 2, x squared plus 2x. If you recall, yes, our last lesson, I told you anytime you're working with fractions like these, you should, if you can, look on the bottom, do what with the bottom? Factor it, all right? All the other problems, I haven't been able to factor anything on bottom, but some of them you can, this one you can. All right, x squared plus 2x, what's the first thing you look for when you're factoring? Greatest common factor. It has a GCF of x. So that factors in x parentheses x plus 2. All right, so now look at the denominators. We have an x plus 2, and an x parentheses x plus 2. What do you think the common denominator is? It's this. It's x parentheses x plus 2. That's my LCD. So let's go through and multiply each part of the problem by that. X plus 2 times each of these. So first fraction, x's cancel out. I'm left with x plus 2 times 1, so x plus 2. Second fraction, x plus 2's cancel. I'm left with, this is a negative 2x times this x, going to be a negative 2x squared, equals, and let's see, over here, x cancels out, x plus 2 cancels out, so I just have that, x minus 6. All right, so let's start combining like terms. Let's subtract this x, and look at that. It's going to cancel out on both sides. That's nice. All right, so let's go ahead and subtract that 2, move that over here also. So that's going to cancel out. Going to have negative 2x squared equals negative 8. I want to solve for x, so let's divide by that negative 2. Bring that over here, so I'm going to have x squared equals positive 4. Remind me again, how do you get rid of that squared? You could take the square root. Now remember, square root method, all right, square root method gives you how many answers? 2 answers. So the answer is not just x equals 2. It's x equals positive and negative 2. All right, now for all these problems, one thing I do want to point out, and I should have said this first, all right, before we say, yay, we've got the answer, if you recall, some of these answers are not quite right because there are some numbers x cannot equal, and really I should have told you this first, and it slipped my mind. Before you even work the problems, really what you should do is just go through and list the things that the variable cannot equal. If you look at the first example, all monomials, what number could you not get on bottom? You cannot get 0 on bottom. All right, so I didn't get 0, so this answer is okay. Same thing in the second example. I didn't get 0 here. B cannot equal 0. I didn't get that. I got negative 1, so this answer is okay. But that's not true for all of these, though, because if you look at example 3, what would give you 0 on bottom? What number plus 1 gives you 0? Negative 1. That's what x cannot equal. All right, I didn't get that. I'm okay. Now in this one, example 4, first of all, I have just an x. I have a monomial, so that it means x cannot equal 0. I didn't get that. And also, what would give you 0 here? X plus 2, negative 2. All right, so x cannot be negative 2 also. Didn't get that? This answer's okay. But the last problem, all right, monomial means x cannot equal 0. I didn't get that. But what will give you 0 here? Negative 2. So the work I got x equals plus or minus 2, but that negative 2 is an extraneous solution. I can't actually use it. It's only x equals 2. So just be careful with these. I should have told you that up front. I'm sorry. But write down first what x cannot equal. Make sure you're not getting that, because if you are, either possibly you made a mistake, or more likely it just had an extraneous solution. It's only x equals positive 2. So y'all go ahead and try the rest of the problems. All right. And let me know if you have any questions. You could check my answer key and email me. Feel free to ask me anything you have trouble with, and I'll be listening. I'll answer it if you have any questions. Bye-bye.